There are places on this planet where the rules change, where water flows uphill, where compasses spin without direction, where objects roll toward you, on their own. Not in science fiction, not in a lab, on Earth, right now, today, and the most unsettling part? Science still doesn't have a complete answer. We're going to visit 5 of them today. Some have been studied for decades. Some were dismissed as optical illusions until researchers went there themselves. But the 5th place on this list, the one we've saved for last, changed the way a team of scientists understood gravity itself. Stay until the end. You need to see this one. 1. Mystery Hill, New Hampshire, USA. Let's start somewhere you can actually visit. Salem, New Hampshire. A quiet stretch of road. Nothing unusual about it, until you park your car, put it in neutral, and it rolls uphill. Locals have called it Mystery Hill for over a century. Cars roll the wrong direction. Water poured on the road defies the slope. Even a ball placed on the ground rolls toward the hill, not away from it. The first time researchers set up instruments here, they expected a simple answer. Optical illusion, maybe, a trick of the tree line. But then something strange happened. Their instruments confirmed the anomaly. GPS elevation readings showed the ground was sloping one direction. Visual perception showed the opposite, and objects, real, physical objects with mass, behaved according to what the eyes saw, not what the instruments measured. So, which one is lying, our eyes or our equipment? That question has never been fully resolved. Some researchers believe it's a profound gravitational gradient, a localized zone where Earth's gravitational pull is subtly, measurably different. Others say the surrounding hills create an almost perfect visual trap. But here's what no one can explain. Why does the anomaly feel stronger in some spots than others? And why have 3 separate surveys over 3 different decades produced 3 different measurements? 2. Hoover Dam, Nevada/Arizona, USA. Now we leave the quiet hills of New England and go somewhere much larger. Something you've probably seen in photographs. The Hoover Dam. One of the most engineered structures on Earth. Built to hold back the Colorado River. Tested for every physical force imaginable. But there's one thing its builders never accounted for. If you stand on the edge of the Hoover Dam and pour a bottle of water over the side, it doesn't fall down. It floats, it rises, it blows back up at you. Thousands of tourists have filmed this. Scientists have studied it. And the explanation, when it finally came, only created more questions. The dam is so massive, so perfectly curved, that it creates its own updraft. A permanent column of rising air, powerful enough to overcome gravity for lightweight objects. Fine. That's physics. Explainable. But here's the part that engineers still argue about. The updraft is consistent. It doesn't change with wind patterns. It doesn't change with temperature. It's been recorded at nearly the same velocity for 80 years. A permanent, man-made gravity anomaly, built by accident, into one of the most carefully designed structures in human history. What else have we built without realizing what we created? This is where it gets weird. Because when researchers modeled the airflow, they found something in the math that didn't add up. The updraft was stronger than the dam's geometry should allow. As if something else, something beneath the dam, was contributing to the force. That report was quietly shelved in 1987. It was never published. 3. The magnetic hill, Leh, India, high in the Himalayas, at over 11,000 feet above sea level, there is a stretch of road near the city of Leh. The locals call it the Magnetic Hill. Turn off your engine, put it in neutral, and your vehicle begins to accelerate forward up a road that appears to climb ahead of you. Not slowly, not barely, up to 20 kilometers per hour on its own. The Indian government has marked this site officially. The Indian Air Force, who operates a base nearby, has logged interference with low-flying aircraft in this corridor. Pilots have reported instruments behaving incorrectly over this specific stretch of land. For years, scientists called it an illusion. Then geologists started digging, not literally, but in the data. And what they found beneath that plateau was extraordinary. A massive iron ore deposit. Deep, dense, running for miles beneath the surface. Iron. The same material compasses used to find magnetic north. And this iron deposit is oriented in a direction that creates a localized magnetic field. One that pulls on metal objects, interferes with radio signals, and may actually be exerting measurable force on vehicles. So, is it an optical illusion? Yes, partially. Is it magnetism? Also, yes, partially. But here's what the researchers couldn't reconcile. The magnetic readings at the hill are significant, but not nearly strong enough to move a car. Something else is happening here, something that sits in the gap between what we can measure and what we can see. And that gap is exactly where the next location lives. We're halfway through, and now, what you're about to hear next changed how scientists see this completely, because the next two locations aren't just curiosities, they're anomalies in Earth's gravitational field itself, measurable, mapped, confirmed by satellite, and they're bigger than any hill, any dam, any road. 4. The Hudson Bay Gravity Anomaly, Canada. From a road in India to something you can only see from space, the Hudson Bay Gravity Anomaly. This is not a local quirk, not a trick of the eye. Hudson Bay, a massive body of water in northeastern Canada, sits in a region where Earth's gravitational pull is measurably, consistently weaker than the rest of the planet. We're not talking about perception. We're talking about GRACE, NASA's gravity recovery and climate experiment. Twin satellites that mapped Earth's gravitational field with unprecedented precision. And Hudson Bay glowed like a hole in the data. You weigh slightly less standing there. Literally, measurably less. The leading theory, the Laurentide ice sheet, a glacier so enormous it covered most of North America 12,000 years ago. When it melted, it removed trillions of tons of weight from the Earth's crust. The crust, relieved, began to slowly rise, a process called glacial isostatic adjustment, and the mantle beneath it, still slowly flowing back into the space left behind, is pulling mass downward, away from the surface. Less mass beneath you, weaker gravity above you. The math works, mostly, but the anomaly is larger than the ice sheet's footprint. It extends beyond the boundaries of where the glacier ever reached. In 2023, researchers published a paper suggesting a second cause: convection currents deep in Earth's mantle, slow, churning flows of semi-molten rock, pulling the crust downward from beneath. Two separate forces, both measurable, neither fully accounting for the scale of what's there. You are being pulled toward the center of the Earth slightly less in this region than anywhere else on the planet, and we built cities in its shadow without ever knowing. 5. The South Atlantic Anomaly. And now, the one we promised you, the one that changed everything. The South Atlantic Anomaly. It's not on the ground, it's above it, a region of space over South America and the South Atlantic Ocean where Earth's magnetic field, which is also a form of gravitational shielding, is dramatically, dangerously weakened. This isn't subtle. Satellites passing through this zone experience electronic malfunctions. The Hubble Space Telescope shuts down non-essential systems every time it crosses this area. The International Space Station, which orbits through the SAA multiple times a day, has recorded elevated radiation levels, unexplained instrument errors, and what astronauts describe as flashes of light seen through closed eyelids. That last part should stay with you. Cosmic radiation, particles moving near the speed of light, are penetrating the weakened field and striking the astronauts' optic nerves directly. The astronauts are seeing the universe through their skulls. NASA tracks this zone obsessively. it is growing. Since the 1950s, the anomaly has drifted westward at approximately 0.3 degrees per year. It is also split. What was once one zone is now showing signs of becoming two. The leading explanation involves Earth's outer core, the churning mass of liquid iron that generates our planet's magnetic field. Something is happening down there. Something is disrupting the field from within. Some researchers believe we are in the early stages of a geomagnetic reversal, a process where Earth's north and south magnetic poles flip. It has happened hundreds of times in Earth's history. The last one was 780,000 years ago, and during a reversal, the protective field weakens globally, not just over the South Atlantic, everywhere. The models suggest this process could take anywhere from 1,000 years to 100. We don't know which, and the zone is getting larger every decade we measure it. 5 places, 5 anomalies. A road in New Hampshire where cars roll the wrong way. A dam that bends water back toward the sky. A plateau in the Himalayas that pulls aircraft off course, a bay in Canada where you weigh less than you should, and a wound in Earth's magnetic field that is growing and splitting above the South Atlantic. Each one has a partial explanation. Each one has a gap, and here's the thread that connects them all. We live on a planet we have not finished understanding. Gravity, the force we experience every second of every day, is the least understood of the 4 fundamental forces. We can measure it. We can predict it. We cannot explain why it exists. We built our entire civilization on the assumption that it works the same everywhere. These 5 places suggest it doesn't. And if 5 anomalies exist that we know about, how many do we not? The universe does not owe us consistency. For most of human history, we believed the Earth was flat. Then we believed it was the center of everything. Then we believed space was empty. Then we believed atoms were the smallest thing. Every time we were certain, we were wrong about something. These places don't prove that gravity is broken. They prove that our understanding of it is incomplete. And somewhere, in the gap between what our instruments say and what our eyes see, and what the universe actually is, something is waiting to be found. Maybe by a scientist with better satellites. Maybe by someone standing on a quiet road in New Hampshire, watching their car roll the wrong way, and asking, for the first time, why? Here's what I want to leave you with. Every single one of these anomalies was discovered by someone who refused to accept the first easy answer. So tell me in the comments, do you think these places are just quirks of geology and physics? Or is there something about gravity we still fundamentally don't understand? Because I've been researching this for months, and I still don't know the answer.